We're gonna start on time today, I think. A little bit early, maybe. What a weird cloudy day. Hello, geometry. It is Tuesday, May 12th. I feel like I'm getting great. 1 o'clock. Trying to load chat on my other computer. There we go. Muted. Perfect. Hello. Welcome back. Today we are going to do some math. We're going to talk about I forget what we're talking about. Amazing. Typical. Typical. Puppy's getting big. Tired. She goes a little crazy. It's a little wild. We're going to do maybe 20 minutes of talking about cones, surface area, and their volume. Should be a pretty easy section. And so is the next one. And then we're done. And then we're going to talk about probability starting next week. Excuse me. You should have or should have access to the Dropbox folder, which has all the assignments in it, but also the student journal pages that I've been adding in every week. And so the student journal page for today, we're in 11.7, looks like, find it, looks like this. This is surface area and volumes of cones. We're looking at cones. These are math cones, not street cones, right? So they're pointy at the top, circle on the bottom, and yeah, we're not doing radians, so we're not really worried, not super worried about these like explorations and things, but we want to talk about surface area and volume. Just like the pyramids that we talked about last week, right? We talked about pyramids on Thursday. Pyramids have 3 pyramids fit in a cube of the same dimension, right? Same thing with the cone and a cylinder, so it's the same formula. That's kind of what that picture is illustrating there, but whoa, we're going to come back to surface area. We're going to talk about volume first. So the volume is the same formula here. So volume of a cone is going to be a third pi r squared times whatever the height is. So it's a third is the key. So it's the third of a cylinder. So volume of a cone, not that screen, sorry, this screen. Volume of a cone is a third of the base times the height, and remember the base is a circle. Right, it's a circle, so it's pi r squared, area of the circle, and then the height of the cone. And that is going to give you units cubed. Okay? So things we want to do with that is calculate how much stuff can we put in a cone. When you think of like the fair and they have those snow cones with those paper cups, they're cones, right? It's folded paper. How much snow cone fits in that cone? And one of the problems I would have had you do, or the project that I would have had you do for the unit, was calculate the volume of that whole thing, the cone plus the circle top. We would have done something like that. Okay. So what we're talking about is, here's our cone, and this one's upside down, and there's the center of our circle, that's the radius and the height. Okay. So, for example, the radius is 3 inches, and the height is 8 inches. What is the volume? The volume is going to equal 1/3 pi r squared, which is 3 squared, times 8. So this 1/3 and this 3 squared is going to divide into just the 3. So this is going to be 3 times 8 pi equal pi. Okay? Pi inches squared. Cubed. Sorry. Cubed. As its volume. Right? So we plug in those things we could solve. If we know the volume, we could solve for the radius. Or if we know two things, we can solve for the missing third, because they're basically three variables. The volume, the radius, and the height. So if we know any two of those, we can solve for the missing third one. Okay? And then we have a surface area formula, which looks like, whoa, okay, so we have a surface area formula that looks like this. So, this is a bit weird, but it's basically two pieces for the surface area. Okay? It has the base piece, so the circle. That's going to be pi r squared. That's going to be easy. And then it's the curved kind of outside of the cone piece on the surface area. So to do this, and the surface area, remember, is like how much paint can we put on this? If this was an orange cone in the middle of the street corner, how much orange would it take to cover up the cone? So the surface area is going to be pi r squared plus pi r times the slant height, or the slant length, so L. So here's our cone. So I'm drawing things. Here's our cone. This is going to be L. The radius, of course, is R, and that's going to give us the surface area. Now, justification for this. No justification for this. Right, or don't know justification. That's fine. So that's the formula we use, which means sometimes you're going to need to calculate L from the height. And that's a right triangle. So we have a right triangle. This is the radius, this is L, and this is the height. Sometimes you're going to need to calculate this from knowing these two. So if our radius is 4, so let's say 4. Radius is 4, the height is 3. We want to find L, so we would do L squared equals 4 squared plus 3 squared. This would be L squared is 25. L is 5. So then we could calculate the surface area using this number. Surface area is going to be equal to pi 4 squared plus pi times 4 times 5. So it's 16 pi plus 20 pi. It's 36 pi. Okay? So sometimes we need to find the slant height of our cone based on the radius and the height. And then we just plug the numbers into the formula and it gives us the surface area. Okay? I think that's it. Man, examples on review, straight out of this student journal. Maybe 2. Yeah, so here's our student journal page. We're going to do number 2 here. Right cone has a diameter and a height. So we want to find the surface area. It's the same formula. Diameter is 8. So this means the radius is half of that, right? Because the diameter radius. So diameter, here's the radius, half of 1.8 is 0.9. And then the height is 3. But we don't have height in here, right? We need a length. So here's our right triangle of our cone. If we spun this around, it would give us the cone. The radius is 0.9, the height here is 3, and we need to find this. So 3 squared plus 0.9 squared equals elsewhere. So we get 9 plus 0.9 squared is going to be 0.81. This L squared, so we get 9.81 L squared, so L is some weird number. Use a calculator to do that, square root of 9.81. This is going to be 3.1420, and it goes on. And from that, we would then use this formula. So I'm going to erase my work so I have room here. But this is our L, so now we can do surface area is pi 0.9 squared plus pi times 0.9 times 3.3. Okay, and so then we plug that into a calculator. Do not do that by hand. We would use a calculator for that. This number times 0.9 plus 9 squared. 3.628 on pi. So I'm leaving everything in terms of pi, not multiplying the number by pi. I'm combining it like it was a variable to keep it. Okay, so that's how we define the surface area. The volume is the same formula as it was before, right? It's the same formula. So we're not gonna. Is the pyramid? I'm not gonna go over those, right? So about 10 minutes today. A little bit shorter, but I think it's going to get shorter this week just because the formulas are simpler. And I'm pretty sure that AP tests are today or this week. I think all of you are prepping for AP tests. Okay, so that's it for today. I'll be back on Thursday. We'll finish chapter 11, and then we will start chapter 12. Talk about probability, odds, dice rolls, all that kind of stuff. Probability, sample size. Okay? So, thanks for watching, and I'll see you guys on Thursday. Have a good week.